When an adhesive sealant fails under mechanical stress, the joint pulls apart and the results are immediate and costly. While field failure is highly visible, factory failure is often hidden in the dead stop of an assembly line, waiting for a slow sealant to skin over. Factory engineers navigate this exact trade-off every single shift. You need absolute structural integrity out in the field, but you also have to maintain a relentless assembly speed. It is easy to look at the 3M 500 series moisture-curing polyurethanes and assume they all perform the same way under pressure. We are skipping the marketing brochures today. We are going to pull the raw numbers directly from the technical and safety data sheets to solve this bottleneck. Because choosing between 3M PU550 and PU560 dictates both your manufacturing output and your product survival. This is the technical data sheet for 3M PU550. It is billed as a multi-purpose sealant, specifically optimized for joints that require a high degree of movement. What makes it unique is its adaptability. By mixing in the AC61 accelerator, you can drastically cut down its cure time on the line. Then we have the 560 cartridge. This is a specialized structural adhesive, engineered specifically for rigid panel bonding. It targets applications where safety and fire codes are strictly enforced. Warning tone. Mix up these two visually identical cartridges and you guarantee yourself either a failed joint in the field or a stalled assembly line. This comparison matrix shows how PU550, the accelerated 550, and PU560 stack up across 4 key mechanical metrics: skin time, hardness, elongation, and tensile strength. Looking first at the baseline PU550, its standout feature is a massive 600% elongation capacity, allowing it to stretch and absorb extreme dynamic shifts. The trade-off for that flexibility is a lower ultimate tensile strength of 3.1 megapascals and a sluggish 50 to 90-minute skin time. If you introduce the AC61 accelerator to the 550, that skin time plummets to just 15 minutes, allowing you to move parts down the line much faster. But speed has a cost. The accelerator requires a dual-pack pneumatic applicator, and it drops your elongation buffer down to 250%. Moving over to PU560, the data shifts toward rigidity. It delivers a superior tensile strength of 4.0 megapascals and cures to a harder Shore A55. That strength means it maxes out around 300% elongation, and without an accelerator option, you are locked into a 50 to 60-minute wait for the skin to form. Notice that neither spec sheet lists a full cure time. 3M only guarantees a cure rate of 4 millimeters per 24 hours for both products, meaning thick beads will take days to fully set. The mechanical reality is clear. PU550 prioritizes dynamic joint flexibility, while PU560 is engineered for structural panel rigidity. Let's map those numbers to the real world, starting with dynamic applications like curtain walls or bonding dissimilar metals. Materials like aluminum and steel expand at different rates in the sun. PU550 is the mandatory choice here because its 600% elongation accommodates that thermal expansion without shearing. However, that same stretch makes it entirely unsuitable for holding up heavy, load-bearing panels. This brings us to rigid panel bonding, like the manufacturing of light rail cars shown here. PU560 is required for these builds. Looking at its industry specifications, it holds specific Federal Railroad Administration and Bombardier certifications for surface flame spread and toxic gas production. You see the exact same demands in aerospace assembly, where structural stiffness and strict fire compliance are mandated by federal law. The selection process must verify both material adhesion and the assembly's compliance with strict industry regulatory codes. We also have to look at the safety realities of bringing either of these chemical formulations onto your factory floor. This safety checklist highlights a major consideration. Both adhesives contain isocyanates, making them Category 1 respiratory and skin sensitizers. The safety data sheet also lists Group 2B carcinogens, specifically titanium dioxide and carbon black, detailing strict exposure limits for both. Applying standard beads of either product requires strict PPE enforcement, including mandatory gloves and localized exhaust or respirator systems. If your process involves spraying PU560 or creates a high splash potential, the hazard profile escalates quickly. In those scenarios, the safety data explicitly states that standard uniforms are insufficient. Your operators must wear polymer laminate aprons or full coveralls to completely prevent skin contact. If you fail to factor in the time it takes operators to suit up and manage these PPE requirements, you will immediately lose any cycle time improvements you gained from the product itself. Let's review the data one last time to establish some clear purchasing directives. Our scorecard for PU550 highlights its extreme flexibility and the ability to hit a 15-minute skin time when paired with the AC61 accelerator. But that flexibility means lower ultimate tensile strength, and hitting that speed requires managing a more complex dual-pack pneumatic system. Looking at the PU560 scorecard, its primary advantages are high structural strength at 4.0 megapascals and those vital transit fire certifications. The trade-off is a rigid final bond and 0 options for accelerating the 50-minute skin time. Here is the rule. Buy PU550 for multi-purpose joint sealing, where accommodating high movement is your primary engineering concern. Buy PU560 if you are manufacturing transit vehicles or need high-strength, rigid panel bonding that complies with federal fire codes. Industrial engineering requires selecting the most effective trade-off for specific assembly line constraints, rather than finding a universal adhesive.